Hello and welcome to Physixify once again, and today we are having problems on chains. Right, we're talking about potential energy once again, how different type of chain problems can come up to you. Let's try to talk about some of them. So we have the first problem coming in something like this. You are being asked to find the gravitational potential energy in all three cases. Now which three cases are there? Here they are. Now if you see case number 1, you have your chain that is h height above the ground. We are also said that the potential energy of the ground is assumed to be 0. What's the second case? The second case is that your chain is vertically like this, such that if you have the whole chain of length h, what would be the potential energy then? And third case, you have the length h chain again, and this time around it is lying horizontally on the ground. What would you do? First case, you can simply say that all the mass, whether here, 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 or here, if you take any mass, it is at a height h. This means all the mass is at height h. You can simply say that u would be equal to mgh. As simple as it gets. What about the second case? The second case is a little more tricky. Why? Because if you see, I would say that if some mass is almost near the ground, there is a counterpart of the mass that is at height h. If there is another mass, let us say that this is at a height of h by 4, then there is a similar mass that is at a height h by 4 from the top. This means I can assume all the mass to be kept at the center point, that is at a distance of h by 2. And in this case, you can say your potential energy would be mgh by 2, because that all mass, if it is kept at a height h by 2, you can easily say that mgh by 2 would be the potential energy. Final case, if I talk about, you can say everything was there on the ground itself. So obviously potential energy in this case becomes 0. Let's talk about a second question. I've written very good because this is actually a good question. It helps you develop an angle as to how you have to approach the problems, right? So what are we said? We are simply being asked what is the potential energy of the chain. The chain is given to you something like this. So there's a hemisphere maybe kept over here, this one, right, that is fixed, and a chain is kept in such a way that it is taking almost half of the hemisphere, right? Now how will you tell the potential energy here? The first thing that comes to my mind is that in the previous cases I could see that all the small little masses on the chain were at a certain place. What about here? Here if you see, you have all different masses at different heights. You have this at a different height, this at a different height, this at a different height, this at a different height. All the heights are different. So what to do? So first thing, I get you a note point that over here you must take a look that all the small masses are at different heights, and if they are at different heights, they are going to have different potential energies. Now over here, what to do? You can use calculus, right? What to do now? Now we must use calculus. So what I'll do is, I am gonna say that let us say we have the same case. This time around, I assume a small little mass. Let us say this mass is just dm, very small mass over here, right? On the chain. How is this mass taken? This is taken such that from the center it is subtending an angle theta, and let us say this small little angle is d theta. Right, now what can you do? Now this thing that I did, that I took this sort of a case where I'm taking an angle theta, taking a small d theta for a small dm mass. This is the basic of calculus that you have to assume somewhere, and this is how we generally do in circular things, that we try to take from the center, we consider a particular angle, and then we change the angle. Now what I will say is that let us say, since I've taken this for a small dm mass, let me consider this height as h for the mass from the ground. So one thing I can say very easily now is that du, that is the small potential energy of the small little mass dm, this should be dm into gh, right? It seems easy right now, but I think you can also see one more thing, because we knew that this h is going to change. So why not change this h into something that is given to us? So I will say that please try to watch this triangle, this, this and this. It's a right angle triangle such that this length is r. If this angle is theta, I hope everybody can say that this h can be written as r sine theta, right? R sine theta, it can be written as. So next step, I have written down h to be as r sine theta. Now what is the problem in front of me? The problem in front of me is that this theta is going to change, but I don't know how to write this mass dm. A lot of students get confused at this point and they don't know what to do. So this is the point where if now you go to mathematics, it can again help you. The physics part I've already done, du equal to dmgh and maybe du equal to dm into gr sine theta. But now the thing that I do, this is very important, this is mathematics again, so right, this is where physics and mathematics sort of relate. What you can say is that the length of this part of the chain, full mass m, is for a length pi r by 2, because total would be 2 pi r. So this much would be pi r. So this much would be only pi r by 2. So pi r by 2 has m mass, and if you talk about this small little mass dm, I can say that the total angle or total length that gets covered, if you try to see the total length that gets covered here, from here till here, this length can be said to be as rd theta, right? Once you see that, if you would have studied this, that if this is r, if this is d theta, this length would be rd theta. And if you use this, you can say that in rd theta, how much mass would be there? This mass would be m divided by this thing into this thing. That is unitary method for you. That if in 2 meter length you are having half meter useful, then in x meters how many is it going to be useful for you? So once you use that unitary method, this thing you get as dm. You put this again, you put this dm up over here, and the next thing that you know is you're gonna get du as something as this, m divided by pi r by 2 into rd theta. This is your dm, and the rest is gr sine theta as it is, you have gotten it. Now what can you do next? If you cancel out r and r over here, if you take this 2 on the upward side, you can see that this is what you get, du as 2m by pi gr sine theta d theta. Now again, if you have made it till here, physics is actually done. Now you need to do a little bit of mathematics. So I hope you are able to see that we integrate now on both the sides. We integrate to get potential energy, we integrate theta, because we know that the value of theta for this element would be 0, and if we go till here, this angle overall would be 90 degree. So we have integrated theta from 0 to 90 degree. And once you do the calculations, I hope you can do that. Final result turns out to be 2 mgr by pi. So I hope that you understood how this very good question was to be done as well. And thanks a lot for watching this class. If you had any doubts, any problems anywhere, do make sure you drop it in the comment section, and make sure that you like, share and subscribe in case you felt that you learned something. Meet you in the next one. Until then, it's take care.